am Manju Singh. I am an assistant professor at HR Group of Institutions, Ghaziabad. Today I am going to teach Research and Methodology, Semester 8th, Pharmacy. Today's topic is Regression Modeling, Unit 4th. So, let us start. First of all, before introducing regression modeling, let us start what is hypothesis testing. Here, hypothesis means a hypothesis, you assume something about any testing, that is hypothesis testing. In this, you just for example, in today's scenario, there is coronavirus and the cases are going very faster in Omicron cases. The daily 100,000 cases are coming in Omicron. So, we make a hypothesis in next 2 days the cases will rise about 10 lakhs or 20 lakhs. So, this is a normal example of hypothesis. When we assume something on the basis of some past results, that is hypothesis. And what about hypothesis testing? Hypothesis testing is making a hypothesis or assumption about a population on the past results or the past experiences or various parameters age, sex, height, health. These are some parameters. So, how we make hypothesis? So, first of all, we collect some data from random areas or some selected areas. Like in corona cases, we take random samples from hospitals. We take data from hospitals, government hospitals, private hospitals, and we make assume the rise in cases of Omicrons. So, which is faster, corona or Omicron? So, we can clearly see the Omicron cases are rising faster than coronavirus, but the Omicron is less fatal than coronavirus. So, these are some hypotheses we take by taking random parameters from any hospitals or our neighborhoods. Then calculating a sample static. In hypothesis, we just assume something, but how we test the hypothesis? So, to test any hypothesis, we put statics. Statics means the calculation. So, using the simple statics to evaluate the hypothesis, this is called as hypothesis testing. We just put statics, or in statics we put like mean, mode, median and so many formulas to generate the result, that is called hypothesis testing. Next, for example, here is second example, the CEO of HDFC Bank. The CEO of HDFC Bank claims that employees' mean age in bank is 35. 2,92,215. There are employees. The employees digit is there are 2,92,215 employees in HDFC Bank, and the CEO of HDFC claims that the employee's mean age, it means he put statics in calculating the hypothesis. So, hypothesis is he just assume, he didn't just calculate everything, he just assume and then confine that the employee's mean age in bank is 35. But how can we prove or disapprove this hypothesis? So, in this we take a random sample. It means for in hypothesis testing we just not collect all the 2 lakh peoples and just note down their ages and then put any formula of mean, median, mode and then take out the random age. This is not, we just take a sample of 500 people. We can easily calculate the data of 500 people, because HDFC bank is a big bank and it has branches all over in India. So, we cannot calculate the age, we can't calculate the age of 2 lakh people. So, we just take the sample of 500 people and find their age. It is easy in comparison of 2 lakh people to take and to find the age of 500 people. So, this is a random sample. If the age is 500 people is near 35, it means there is a mean. Mean age means 1, 2, 3, 500. 500. Age means 50, 22, 21 or whatever the age, we can calculate the mean age. So, if it is near 35, it means it can be 34, 33. Near 35, not actual 35. So, we can say there is no evidence to reject the hypothesis. If it is near 35, so we can say the hypothesis or the assumption made by the CEO of HDFC is right. We cannot reject it simply. So, but what if the sample average age is lower or higher than 35? Here you can see we only took sample of 500 people from 2 lakh people. We take sample of only 500 people, and if it is 35 then it is hypothesis is okay. But what if it is lower than 35? We cannot also reject the hypothesis, because we randomly take sample of 500 people. Suppose the HDFC branches in Kolkata, Delhi and various in Delhi. Age is all are young, all are up to 20 to 40, but in Kolkata 41, 42, and we just took the sample of 500 in Delhi. So, we cannot also reject it. So, how far is really far? So, how it is really correct or not? We want to quantify the severity of deviation. So, we have to take the probability of this occurrence. If it is really low, then we say we reject null hypothesis. We will read null hypothesis in next PPT. If we are just randomly taking the sample, so if it is 34, 35, it means if it is near 35 then it is okay, hypothesis is okay. But what if it 30, 29, we have to reject the hypothesis. What is null hypothesis? Null means simply nothing. What is null hypothesis? Null hypothesis, H naught represents null hypothesis. It is a theory that has been put forward either because it is believed to be true or because it is used as a basis for an argument and has not been proven. A null hypothesis is what? It is believed to be true. It is again an assumption that null hypothesis is true, and it is the base for an argument. It provides a base for any argument, but it has not been proven. It has never proven. So, that is why it is called null. Null means nothing. For example, in a clinical trial of a new drug is no better on average than the current drug. It means if we are conducting any clinical trial of a new drug, but the new drug is not average or not good than the current drug, we would write null. H naught means null hypothesis. There is no difference between the two drugs on an average. This was an assumption which is believed to be true and used as a base for an argument, but it has not proven, it has not been proven. So, we can assume there is no difference between the two drugs on an average. Next is, what is alternative hypothesis? Denoted by HA, alternative hypothesis. It is also a statement of what a statistical hypothesis test is set up to establish. For example, in the clinical trial of a new drug, the alternative hypothesis might be that the new drug has a different effect on an average compared to that of the current drug. Alternative null hypothesis states that there is no difference between the current drug and the new drug on an average, but in the alternative hypothesis we assumed that the new drug, we just assume the new drug has a different effect on average compared to the current drug. So, here we can write, this is a symbol of alternative hypothesis. A means alternative and H means hypothesis. Two drugs have different effects. The new drug is better than the current drug on average, means we take the average, and on average the new drug is better than the current drug. This is our alternative hypothesis. So, the result of hypothesis test is reject HO in favor of HA or do not reject. It means this is, there is a probability. H naught is null hypothesis and HA is alternative hypothesis. Reject null hypothesis in favor of alternative hypothesis or do not reject null hypothesis. Next is regression analysis, the topic. From here our topic has actually started. So, what is regression? First of all, what is regression? Regression is to find the unknown value of something from a non value, like we have to find x. This is a unknown value and we have to find x, the unknown value, from the non value, it means y, but we know that y equals to 20. So, we can find the unknown value from a non value is known as regression, to predict the unknown value from a non or reference value. So, regression is of two types. Regression is of two types, simple and multiple. In simple regression, we have two values, two variables, but in multiple regression analysis or regression, we have more than two variables. For example, in regression, in simple regression where there is two variable, for example, you have to predict the height of child by from his parents' height, like his father is tall and mother also tall, then you can easily predict the height of a child, any child whose father and mother are tall. So, this is an example of simple regression where there are two variables and from one non value can predict the unknown value of other thing. In next case, in multiple regression, you can say that there are 4 children and a father is a scientist, he is very intelligent. You cannot predict the intelligence of all 4 children. You can assume only that they can be smart or intelligent in the same way of their father, but not actually make any assumption. Next example of simple regression is like the hair color. If father hair color is black or mother hair color is also black, then definitely the child hair color will also be black. Next, regression analysis. What regression analysis actually means? So, it is the relationship between two variables or two or more variables is known as regression analysis. Analysis, you also know that to analyze something. So, the relationship here I write the relationship between two or more variables is known as regression analysis. Okay, and here I need to write something. And you denote regression analysis is y equals to a plus b x. Here x is the non value, this is non, or we can say it as the predictor or regressor. The non value is known as regressor, here x, and we have to find y. Y is the non value and it is known as regressed. Okay. A is the intercept and b is the slope. So, in this we do when we make any graph, this is y, suppose this is y, this is 0, 1, 2 and 3, and this is x, 0, 1, 2, 3, 4. This is non value x and this is also known as regressor. This is a non value and this is known as regressed. So, what is intercept? Intercept is the line which touch y. From where this line touch slope touch y is known as the intercept value, and this is a and this is our slope b. So, this is regression, simply this is regression, already mentioned is second unit. Next is simple linear regression model. What is simple linear regression model? It is a statistical method that allows to summarize and study relationships between two continuous variables. It is a statistical method, means calculation, which allows to summarize and study relationships between two continuous variables. The factor that is being predicted is called the dependent variable. It means y equals to a plus b x. This is a non value and it is dependent on x, which is a non value. So, this is independent, sorry, this is dependent and this is independent. The factors that are used to predict the value of the dependent are called independent variables. It means this is independent. In linear regression, Each observation consists of dependent variable and independent variable. It means this is the equation of regression and it consists both dependent and independent variables, which makes a straight line shows the relationship between the dependent and independent variables in the simple regression model. I have shown you earlier, this is y, this is x, and the line, this shows the relationship between the dependent and independent variable in simple regression method. Okay. Next, the simple linear regression model equation like y equals to b naught b1x plus implies, here this is known as error in linear regression model. Y dependent, x independent, b naught is intercept of line. I told you intercept, the slope, where the slope touches the y is known as the intercept, and b1 is the slope. This slope is known as b1, this is not as b naught. The intercept b naught represents the predicted value of y where x equals to 0. Here x is 0, y is 0, and it touches y. The slope beta 1 represents the average predicted change in y resulting from a unit increase in x. As it increases, we can predict the value of y like this. The random error, here this term is known as random error, is assumed to follow the normal distribution with the mean of 0 and variance of, this is theta square. Hypothesis test can be carried out if it can be assumed that the random error is normally and independently distributed with a mean of 0 and variance of theta square. Here the hypothesis test is expressed as h naught equals to b1 equals to b1 0, h1 equals to b1 not equal to b1 and 0. b1 0 is the value like 1 0. The test statics used for this test is as follows: t equals to b1 head minus b1 0 upon SE b1 head. This is b1 head and SE denotes standard error. Okay. Next is b1 equals to least square estimate of b1 and SE b1 head 1 is standard error. Here there is a equation and this is SE this is null hypothesis is accepted if the t value of the test statics is as follows, where t alpha upon 2 and minus 2 and minus t, here minus t upon alpha upon 2 and minus 2 are the critical values for the two sided hypothesis. Alpha equals to significance level and minus 2 is degrees of freedom. You have already read what is degrees of freedom. N equals to total number of observations. Example, if it may fail to reject, this is null hypothesis, beta 1 equals to 0, then it shows non-linear relationship between x and y. It represents the particular case where no model exists for the observed data, figure 1, or it may represent the case where the true relationship between x and y is not linear, figure 2. Here it represents the practical case where no model exists for the observed data in figure 1. Figure 1 is this. No model represents for figure 1. N is next to or it may represent the case where the true relationship between x and y is not linear, figure 2. In figure 2, here this is like this is, in figure 2 this is like this is like this. So, there is no true relationship. X and y is not linear. If H null hypothesis beta 1 equals to 0 is rejected, then it shows that a model exists between x and y in figure 3. So, in figure 3 there is a model. This was like, sorry, this is not like this. This was like this, and third, this one is like this. Figure 4 represent the case where the linear model is sufficient, and the case in figure 4 shows the higher order may be needed. Multiple regression model is like statistical techniques in which you use several explanatory variables to predict the outcome of responsible variable. The goal of multiple linear regression is to model the relationship between the independent and dependent variables. It means in multiple regression the extension of ordinary least square regression, because it involves more than one explanatory variable. These are some formulas and calculations we use in multiple linear regression. Linear regression only used when has two continuous variables, an independent variable and a dependent, but in multiple regression model several explanatory variables is present. The independent variables are not highly correlated with each other. Y1 is observations are selected independently and randomly from the population. Residuals should be normally distributed with a mean of 0 and variance. How to use multiple linear regression? An example, analyst want to know how the movement of market affect the price of Sony Ericsson phone. In this case, the linear equation will have only two values, like customers demand and the production value. These are only two values, but in reality not only two factors affect the sale of phones. So, there are multiple factors, like price movement of Sony phone depends on performance of overall market. Other predictors are price of oil, interest rates, price movement. So, all these factors determine the sale of phone. Thank you.